Hi, this is Varun from Quantus Product Engineering. Today I am going to talk about inductance extraction in Quantus. First, let's talk about why we need inductance extraction. As we progress through advanced nodes and we have more and more metal layers, we see that the top metal layers, which are wider, are more sensitive to inductance effects. The bottom layers are more sensitive to RCs. Due to this inductance effect, we see things like ringing effect and voltage overshoot happening on signals. In order to solve this problem, Quantus has come up with inductance extraction, which covers skin effect, proximity effect, return path detection using peak and broadband ladder network methodologies. For example, on a typical 10 nanometer node, we see delays of up to 13 picoseconds and 12% overshoot, and this is something that we need to solve as a design community. So what Quantus has done is we have two particular solutions, one for cell flow and one for the transistor level flow. In the cell level flow, we have Quantus through Innovus extracting RCs on all signals and inductance for clock signals, and we then stitch them all back together through an SDC and provide it to Tempus to calculate the effect of inductance. On the transistor level flow, we have the layout schematic going through LVS and then to Quantus, and Quantus then outputs inductance through a DSPF or SPICE formats, which go into MSPS, Spectre or substrate noise analysis. So with respect to accuracy and correlation, what we have observed is Quantus is highly accurate across all frequency ranges and correlates really tightly to fast Henry. Thank you.